Okay, so let's look at some 2D drawings. These are the drawings that you did earlier in part 3. They just happen to be typed up right now, so they might look a little neater than what you did on paper, but they should be very, very similar. Okay, this is the process that your brain should go through when you're trying to figure out what 3D shape it has. So you're first going to ask yourself, how many atoms are bonded to the central atom? That's going to narrow things down for you. Then you're going to look a little bit more closely at your center atom, and you're going to look at the number of pairs of unshared electrons. And then you should be able to pinpoint exactly which 3D shape it's going to take. So here, we have 2 atoms bonded to the center. So that means it could either be linear or bent, because linear or bent both could have 2 atoms bonded to the center. They could be in a straight line, 1, 2, or they could be bent down, 1, 2. So we at least know we're going to be either linear or bent. So I'm going to get rid of these options here. The next thing I look for is the pairs of unshared. So I look at my drawing and I look on the center atom. I can't stress this enough. Center atom only. We don't care what's on the outer guys. Center atom. So oxygen's my center. Are there unshared pairs? Yes, there's 1, 2 sets. That puts us here. This is bent. So in the real world, if I was to redraw this, oxygen would be up high and the hydrogens would be down low. It would look like this. So there's my 2 unshared pairs of electrons, and there's my 2 hydrogens bent down low. Remember, I can't use a ruler and touch all 3 atoms at the same time. It's bent because of these electrons. If they weren't there, it'd be linear. That's why it's so important that you, on your 2D drawings, make sure you include them on your center atom. If you forgot them, everything would be all messed up. Okay, let's look at the next one. We've got 4 atoms bonded to the center. 1, 2, 3, 4. This is easy because what's the only one with 4? Tetrahedral. There's no electrons on the center. We can't fit them. It's already got 8 electrons in all those bonds, so it's automatically tetrahedral. The next one. How many atoms are bonded to the center? 3. 1, 2, 3. That puts us in the trigonal world, either here or here, because they both have 3. What we need to do next is zoom in and look at the pairs of unshared electrons on the center. So you look at your center atom, which is nitrogen, and there is a pair. There is 1 pair. So that means it's here, trigonal pyramidal. Trigonal pyramidal. So if we were to look at this in the real world, it would have 3 atoms bonded to the center. They would sit as the base of the pyramid, and then those extra electrons up here is what's causing it to bend and look like a pyramid. Otherwise, it would be planar. But because they're there, that's why it's so important not to forget them. Because they're there, it bends it down. So when you make your drawings, you cannot forget to put those extra electrons, if they're there, on the center atom. Now, the next picture also has 1, 2, 3 atoms bonded to the center. So again, we're in this red range, trigonal pyramidal or trigonal planar. We look more closely at the unshared electrons on the center atom, and we don't see any. Instead of putting them in there, we must have run out. Instead, there's a double bond. So there's 0 unshared, which puts us here, trigonal planar. That molecule looks like this. 3 atoms bonded to the center. Now, one of them is a double bond, so I'm going to switch one out. I'll take out a single bond and put in a double bond, but notice how it's still the exact same thing. These atoms are 120 degrees away from each other. The electron cloud of each of these, in this case oxygens, like to repel. This is what it looks like in 2 dimensions. Left, right, top. We don't even have a bottom here. But in 3D, it looks like this. Yes, they're in the same plane, but they're spread out more. So if I ask you to draw this in 3D, you wouldn't recreate this 90-degree business. You would put one at the top, one in the center, and then these guys would go down 120 degrees. This kind of looks just like that. except it's across and down. That's two-dimensional. Left, right, top, bottom. But if I say draw this in 3 dimensions, you would have to make it look like a pyramid. You would have to make it look like this. The center atom would have to be up high, and then the other guys would have to form the base of the pyramid. So they look different. All right, finally, we've got 2 atoms bonded to the center, so that puts us back here in the blue range. It could be either linear or bent. 1, 2. And then we zoom in and look at our center atom, and we see no unshared electrons. There's no reason for these guys to bend down and get closer together. There's not a third region of negativeness. Oops. We have 2 double bonded oxygens on either side, and they're 120 degrees away from each other. If we had extra electrons, then they would get closer, they would bend, but we don't have them. So they're nice and wide. So this is linear, a straight line. And if I asked you to draw this 3D, well, it would be the same thing. You wouldn't have to really redraw this. But this one is not linear. You would have to redraw it bent. All right, try the next few out real quick. Hit pause, try them, and then come back. I'm going to give you the answers fast. All right, first one here. The only way you can connect 2 atoms is linear. Remember I said always designate one as your center and then make the other one outer, and that'll help clarify things. So how many atoms are bonded to the center? Just one, just this guy. Are there any pairs of unshared on the center? Yeah, there's one, but it's also balanced by the other. So that really doesn't come into play here. The only way you can connect 2 things is with a straight line. So if you only have 2, you don't have to worry about this. But we have 3 here, 3 atoms total. 2 of them are bonded to the center. We do have to worry about our center atom. This also puts us in either linear or bent. We look at our center atom. There's 2 electrons pushing down on these oxygens, so that makes it bent. So if I said redraw this, make it 3D, you would put the oxygen in the middle up high, and then these guys would be bent down because of those. This one, there's 4 atoms bonded to the center, no extra unpaired, so that's tetrahedral. Anytime you have 4, it's tetra. This, we have 3 atoms bonded to the center, so that's going to put us in the trigonal world, either trigonal pyramidal or trigonal planar. We don't know which one until we zoom in and look at our center atom. The center atom has no extra electrons pushing these guys down or away, forming a base of a pyramid. So since they're not there, it's trigonal planar. If I said redraw this, you would put the nitrogen in the middle, and you would spread these guys out as equally as you can, 120 degrees away from each other. If those electrons were there, then it's a different story. If they were there, then it would look like a pyramid because of them. But since they're not there, we don't see that. It's planar. It looks like this. They're all in the same plane. So we could lay this flat and it would all touch. We could slice through this and touch all the atoms because they're all on the same plane. You change those center electrons and it's a different ball game. But this model didn't have them, so it's planar. And that's it for shapes.